Okay, so we're going to discuss a couple of key things about the syntax, and then we're going to build this. I'm going to show you how to go through the build process so that you can start writing your own code and writing your own programs from the command line. Now, I will give you this little bit of hope. Once we get through this command line process and I just show you how it works, we're actually going to move on to an IDE. I wanted to show you the basics of how to do this, but I'm actually going to move on to an IDE so that we can focus on the language and not spend so much time building and compiling and going through this process. But I did want you to see it at first. So, one quick thing before we do this. I said that you, in functions, you call them by writing their name out and then passing in arguments. We passed in hello world, and these two quotes, double quotes, say this is text. It's saying this is a string of characters. That is, it's a string. It's text. It goes together. It's like a sentence. But this looks funny. It's like, okay, I expected in a hello world program that we would write out hello world, what's with the \n. Well, this is a key thing that I wanted you to think about when the program's being compiled. There's a thing called white space. So if I hit a space here and I move my cursor over, or tab, as far as you're concerned from a user's standpoint, and if you're new to programming, you don't typically wouldn't think about this. You think, well, I just moved my cursor over. But if you think about it for a second, how does the program know? How does Notepad know to hold the cursor there and rather than where it was at? Well, behind the scenes, these invisible characters are actually represented in code by values. So the white space has a value, or the space. The tab has a value. So there are, several different types of invisible characters. And you got to ask yourself, enter, character term, line feed. You got to ask yourself, how are those represented? Well, in our code, at the C level, at the higher level, we have, if we want to include those in our output, we have to be able to tell the C language that I want to include a tab. So in that case, it would be a \t. This is called an escape character. And for this, we have a \n, which says new line, and there are several escape characters. But when that compiler is reading all of this text, right, and it's going through and it's trying to figure out what you mean by semicolons and parentheses and that sort of thing, if inside of strings, if inside of these double quotes, it comes across a backslash, and then after that backslash, you have an N or a T, it says, okay, insert the values behind the scenes that make this white space, or an enter, or a tab. Because when this goes through the compiler, all of this white space, all of this dead space that we don't see, that's structure in our program, is ignored. It's completely done away with, except the white space that we enter in the format that we're giving back to the person running the program. So I wanted to get that idea that when we're compiling things, all of this is fed in as a string of text, and the white space in the C language is completely ignored and just completely ignored, done away with, so that it can actually understand and say, okay, I've got an open brace, and then after the open brace, I've got print f. Okay, I've got open parentheses, so the printf function, is he passing anything in? Yes, an open quote, so these are some letters. Oh, I got a backspace or backslash and an N, so that I'll insert a new line, double quote, parentheses, semicolon, so this is a whole statement, where we call printf, and we pass in a string of characters. So that's kind of how the compiler is working behind the scenes when it's churning along and trying to spit out output. So if there's a certain way that you like to write your programs, just know that new line characters and white space is completely ignored, and you can write it in as funky way as you want to if your eyes. I wouldn't suggest it. typically developers will have a style that they have where they indent or tab to so many spaces, and this is how they organize their code because their eyes get used to seeing it that way, and it's easier for other developers coming after them to read. So with all that said, let's compile this. Now I want you to save it, and if you remember the two folders that I discussed in the last video, File, Save As, I'm going to save in the C source folder, and I'm going to save it as helloworld.c because the .c extension represents that it's a C file. So even though it's all text, it is a C file. That's what we're telling the compiler. This is a C file that I want you to compile. So save it as that, which I already have. And now we've got to identify three key things here. We've got to identify in the command line where our compiler is. We've got to identify the code file that we want to pass to the compiler. And we've got to identify the output location that we want our code to end, where we want our code to end up. Now we define that. We know those things if you think about it. Whenever we installed mingw in the root in C, that directory, we looked at our compiler and we know it's going to be there. We are saving our code in the in this case on the desktop, and it's in a directory called C source. And we said we wanted to shoot our output, our executables out to the C tutorial directory. So we got to get to those, and we got to put those together. So let's open command prompt. This may be hard to see. Let's open the command prompt. Okay. And the first command we're going to do is I'm going to go cd, which is change directory, space. So that's a mini program that changes your current working directory. Change directory. I'm going to type in mingw. Okay, so I'm in C mingw. Now, I'm going to type dir, and dir lists the things that are in the directory, the files in other directories or folders. So bin is the folder that we're going to be in, that we're looking for. So lib, library, bin, binary. We're going to look for our compiler. So let's change the directory, cd space bin. So now we're here. So we could, this is the same thing as going through our file explorer down here and trying to find our file and double clicking it. But once you get familiar with this, you can actually churn through the command line very quickly once you learn the keywords and how to string them together. But we're trying to build from the command line here. So now we're going to look for, okay, oh, so we got a lot of stuff here. We're looking for gcc.exe. So we type gcc.exe. That's how you run a program, is you type its name or that file's name in the command line and it gets loaded up and ran. But we actually need to provide it with some information. So the first thing that we need to provide it with is what file are we passing in that we want to be compiled. So we're going to go out here real quick and we're going to say C source. I'm going to right click properties. I'm going to open it first. I'm going to go to helloworld.c and I'm going to right click and go to properties. I'm going to find its location, which is this. Okay. I'm going to copy it. I'll go back here. Now there are other ways of doing this, and I know this is I'm using the GUI, but I just wanted you to see what was happening. So I'm going to do a double quote, and then I'm going to fill in. I'm going to say I want you to take, so I'm going to add a backslash, and I want you to take the hello world file and compile it. So I put that in quotes. The reason I put that in quotes is we have spaces here, and like we discussed with the new line character and empty white spaces, if we didn't have these double quotes, when it got to desktop \C, it would say, oh, white space, it's done. So spaces say, or what it uses to determine where a program being called ends and its arguments begin. Now we have a switch, which is additions, can think of them as extensions to the program. We're going to hit space, hyphen O, that is output. Where do we want the output to go? Space. Oh no, I can't believe I did that. I accidentally erased it. Let me get it back real quick. I hit up. If you hit the up arrow, it accidentally erases it. Or it's a history. I'll show you. We're actually going to use it in a second. Hyphen O, and I'm going to hit V again, and I'm going to go change this to tutorial output, and I want to define what I want the file name to be. I need to put double quotes here. Define what I want the output to be. So I'm going to want that output to be hello world.exe. So I'm saying call gcc.exe, call the compiler, space, which says, okay, give me the file that I want to pass in. Got a double quote. Find that file, so full path, the absolute path. Then space, then output, hyphen O, another double quotes, the directory of the output, and the name of the file, helloworld.exe. So we're set up. We've got the location of the compiler, location of the source code, and where we want the output to go. Hit enter. Bam. Nothing happened, but it did. What happened was, in this folder, in the C tutorial output folder, our hello world file was created. Now if you double click it, it just kind of flashes. Like, oh man, well it didn't work. It did work. It worked very successfully, but if you got to think about how quickly a single statement would execute and run, it brought the command prompt up. If you double click it, you'll see a flash. Command prompt runs. It enters your main method that you defined. It calls printf, and it exits that quickly. So let's look at it. So that was one way to call it, and this actually shows you how the command line is related to the user interface, that they both do the same things. It's just how you get to what they do is from two different angles. So we know the directory that it's in. So I hit up. I just pushed the up arrow just so that I could change my directory. So CD space, and I want to get in the hello world. I want to get in the hello world folder. So change directory to that. There. I've hit dir. I've got one file. I've got the hello world.exe. Just like I called gcc.exe, I'm going to call hello world.exe, the file that I just created. .exe. I'm going to hit it, and there we go. We've gone all the way around the world and done the most, well, not the most, but a very inefficient way of programming. But it is the old school way. There are even ways beyond this, but this is what's happening behind the scenes when you click that play button, that hit F5. If you're coming from other programs, is the files are getting put together. Like in C and C#, the project files, what's being included in the assembly, are all getting put together and linked and compiled and sent to output into a debug or release folder, bin folder. Same thing's happening here. We found the compiler, we passed in our file into the compiler, we said we want our output to go to a certain place and be a certain name, and then we ran it. And you'll see here we have hello world, printf inserts a new line, and then it also inserts the other new line that we added, the \n. And so that's a very, I know that's dense, and if you're new to this, it's a lot of new material, and we're going to go into an easier way of doing it after this. But that is how you use the command line to bring files together to create executables that actually run on your computer. So it will get easier, I promise. But pat yourself on the back, because it should feel good to be able to know how to do that.